Welcome back. So I'm going to be doing another talk here on StereoKit. And this particular presentation is going to be very much in the weeds. So this is kind of like, I just wanted to show people like what it's like inside of the StereoKit's core, like how it's organized. This is like partially, I would really love to have people contributing to it. But on the other side, this is also really great if you just want to understand what's going on. So I'm going to be showing a lot of kind of C code sort of stuff here. I'm going to try not to get like too into the details or anything. Like I'll show you some of the organization and structure of this stuff. But you will see some C code here. So, all right. First, a little bit about me. So the wonderful thing about having these 3 back-to-back presentations is that I get to introduce myself each time to the same people. So a little bit about myself. I actually started coding when I was around 12 years old or so. I was determined to become a game developer, and back when I was, a wee little lad, there wasn't really such a thing as a game engine, so you basically had to write your tech from scratch. And I had the misfortune of picking Morrowind as my inspiration, and so I was like, I'm going to make open world video games, and I'm going to do it on DirectX 6. Like that sort of thing. So I actually spent a large chunk of my childhood writing game engine stuff. So like this thing over here on the left, this is the first engine that I wrote. It actually ended up being in DirectX 9. It took me that long to figure things out. And I did actually have an open world engine with user interface and editor capabilities and everything like that. And what do you know? If you spend your whole life making engines, you aren't very good at making games. So I've actually made a couple of different engines over the years. This one I think is one of my more recent ones. This is a WebGL graphics renderer. I was really into WebGL when it first came out, and I was like, yeah, this is awesome. I went to SIGGRAPH and implemented everything I saw. So I had a really cool WebGL renderer, and then also never used it for anything. So guess what I'm back at again? I'm building a mixed reality engine, and I think this one's pretty swell. So this is, I don't know, 4th, 5th, 6th stab at making an engine. This one is not particularly focused on games this time, but that won't stop me from making games with it. But it's still really good for the rest of you app developers. So that's kind of a little bit of my background. So I'm going to first introduce you to the stuff that's out there. So this is lower level architecture stuff. So I am actually going to talk about the GitHub repository. If you are consuming StereoKit, you don't really need to do much with the repository. But that's this talk. So first things first. So we have this StereoKit organization here, which I might have open it. I have no good sense of tabs here. So this is the StereoKit organization. It has a whole bunch of stuff in it. The StereoKit one right here is the core thing where everything that's really part of the engine resides. There's SKGPU, which is a slightly separate project. This is some of the rendering code for StereoKit. It's taken out, it stands on its own. You can do a few rendering projects even without StereoKit, the rest of StereoKit. And then I have a bunch of templates and examples and stuff like that. So this is the main one that we're interested in, StereoKit/StereoKit. So off here, a couple of different folders. The big important ones, there's StereoKit and there's StereoKit C. So StereoKit C is where all the really interesting stuff is. This is, well, actually, I probably should go back for it a little bit and do my slides instead of this part. But so this is where all the C code lives. This is the core part of StereoKit. Then there's also StereoKit. This is the C# part of StereoKit. You can basically think of the C# part as first-class bindings to the C code. I spend a lot of time on this, and I make sure that it's really, really good, but all the functionality is actually down here. I then have a lot of examples. So this actually includes a C++ test, a C++ test on Android. This is all the C# tests. And then I actually have a test for V and Zig, if you're familiar with those. These aren't super robust, but they're there kind of just as part of the interop story. Like, I really like the idea that StereoKit can theoretically be bound to a lot of other different languages later on. There are actually some people working on some Rust bindings to StereoKit, which is pretty cool. So that's under the examples there. And then I have a bunch of templates. These are kind of like the stuff that you see on Visual Studio. This is where those are generated from. I have a bunch of tools here. This takes some of the C code and translates it into C#. This also will later do some of the bindings. Like I would love to generate like C++ bindings or possibly Python bindings. Like I think some of those might be really cool. The Documenter project, which generates the website. This also runs a lot of tests as well. This was an older stab at API generation. I have a little bit of analytics data to say like, okay, why is my file so big? Like actually, check this out, buildinfo.md. So this is the current file size of each binary for StereoKit. This is embedded in the repository so I can see how it's changing over time. So when I ship an update, I go, oh, well, this update is like 100 kilobytes larger than my last one. Why is that? Which is really nice. I like being able to pay attention to this stuff because this is meaningful when you're shipping something that you want people to depend on. Like some interesting things, like I'm still not sure why the Linux binary is 4 megabytes, and I need to go investigate that. But I'm happy about the Win32 size. Like this is kind of nice. Similarly, there's a bunch of PowerShells in here for like updating certain components or like, I think this one in particular will build the entire project and create binaries for each individual platform and all that fun stuff. This one will update OpenXR. So if OpenXR comes up with a new version, then this will go get all the right files. And then these two, I have my own shader compiler that I wrote. So this is also over in the skgpu repository. It's technically based on a couple of other different shader compilers, so I'm not really compiling anything new here. I'm just like tying these all together and putting them into a format that is portable across many different places. So this thing's real fun and interesting. Anyhow, back here. So that's kind of like approximately what's in the GitHub repository. A bunch of interesting stuff there. So I mentioned this. StereoKit's core is C and C++. So this is kind of interesting and important. First of all, writing in C is actually really nice. This was something I didn't realize how nice this was until I came back to it. I kind of started my life as a C, C++ developer doing DirectX 9 stuff. And then I spent like 5 years with XNA. And I loved C# so much. I was like, oh, yes, I stopped writing bugs. This is amazing. And then I spent like another 10 years with Unity doing C# there. And like they kept getting better over time. And that was really great. And then I came back to OpenXR and doing C stuff. And like everything had gotten so much better than it used to be. So I've really been enjoying coming back to C. So another interesting thing here is that I don't use C++ really. I think I'll talk about that a little bit more later, actually. So yes, so StereoKit.h is completely C compatible. It's not C++ for StereoKit.h. Some of the code inside of StereoKit is C++. This is usually for interacting with different libraries and stuff like that. It's kind of unavoidable. The DLL is 1.8 megabytes. So I really wanted StereoKit to be good for middleware. So StereoKit is lightweight. It's not very opinionated about architecture. I really wanted people to build stuff on top of StereoKit. And so far, it's actually been pretty successful. I think one of my favorite examples of this is actually Stardust on Linux. So this is basically a mixed reality display driver or operating system shell that is based entirely on StereoKit, among other things. And it's the rendering engine for it, which is really amazing. So it does work really well as this middleware sort of layer, this lightweight layer that just takes care of the rendering for you and lets you focus on the other harder stuff. As far as dependencies go, I don't depend on a whole lot. I have a bunch of single header libraries. If you've done C++ code, like single header libraries are the bomb. And I try to use pretty much just those. The only exceptions are OpenXR's loader itself and React Physics. And honestly, React Physics is a little bit too C++y and I really need to get rid of it because it's a third of my binary size. OpenXR loader is the second largest thing in my library as well. So I'd love to peek into OpenXR loader and see if I can shave it down. Okay, and also, so a note on the naming conventions. So because C# is mostly just a binding to C, the names are very similar to each other. So if you see something like model.draw, in C, this is model_draw, basically. It's just a very small translation. So if you see one name, it basically maps to the other one. And so if you're looking at like documentation or trying to figure out how this maps to something that you've already seen, that's kind of how. Okay, so a little bit about the code style. So I mentioned a little bit about liking C. I actually started StereoKit using the standard library and doing it kind of the C++ way. And about a month later, I decided that that was all a really big mistake. I actually don't like C++. I don't like the standard library. It was a big problem for me. Like StereoKit would probably be about 5 times the binary size right now if I was still using C++ in the standard library. So I code in a C style, and I use C libraries. And it's a little bit more work sometimes, but it is a much better quality product because of that. One of my favorite things about removing object-oriented style code is that you no longer have hidden bits of code floating around. So like if you have a constructor or operator overload or some copy constructor thing, like honestly, like those are all invisible and they trip me up all the time. Maybe I'm just not good at it, but it's just really hard to figure out what's going on with C++ code. My least favorite thing ever is writing WinRT stuff for when I have to interact with UWP. It's like not fun at all. So I stick with C. Plain old data is kind of an interesting way to encapsulate some of this idea. So if you have like a struct, that struct is just a struct. That struct has no constructor, it has no destructor, it has no methods attached to it. And that really simplifies a lot of the code. And honestly, like I've been really pleased. When I do have bugs in StereoKit, they're really easy to find. This has been absolutely a joy. I don't write a whole lot of bugs with this, but they're easy to find when I have them. I work with raw pointers all the time. I have never had issues with memory corruption or anything like that. It's just, people may be a little scared of some of this stuff, but it's not really all that bad if you're not abusing things too much. So that's kind of what the code looks like under the hood. So I have a concept in StereoKit called systems. So this is kind of how all the code works together and kind of interacts with the main loop. And so this is actually what happens in the console when you run the application. It'll start outputting a log with skinfo, skwarn, or whatever. And when the application shuts down, it gives you this little performance report. And this is a really good insight into like what the systems kind of look like. So this just tells you like the name of the system, how long that system took during initialization, how long it took during update on average, and same thing with shutdown. And if they don't have an entry there, it's because they didn't have an update or initialization for that particular system. These in particular are sorted in order of execution for update, and there is a separate order of execution for initialization. But each one of these controls a different item here. And you can actually see app there right in the middle. That's actually the application code that is your stuff. And so you can kind of look at that and say like, oh, my code is taking about 1.1 milliseconds of the frame time. So that this is kind of a nice little view to have at the end of the application, but it also is like, well, if I want to know what order these systems execute in, you can just take a look at this and see it, like, oh, executes like that. And so if you're interested in like, have some new high-level system like the lines or something like that, and you want to add it in, then you can basically, so this is, I think this is in like StereoKit.cpp or something like this, and it kind of looks like this. You just say like, here's a new system, here's what my initialization dependency are, and I just say like, I depend on platform and defaults. So it's going to be after these things. And for update, it depends on frame begin, and so it's going to be after frame begin. And I just do like a topological sort once I have all of these systems, and it puts them in the right order and tells me if there's conflicts and stuff like that. And then I just have a couple of function pointers. So function pointers are something that I do try to avoid, because these are another example of invisible code. Like if you have a function pointer, you don't actually know it's in that function. And so it's kind of like, where does that go? How does the code execute from here? And this is one of the few places where I kind of made an exception for that. I'm like, this is a good use for function pointers. So it's just initialize, update, shut down, and then you add the system. So if you wanted to add a new system, this is what it would look like. and then you can fit it in wherever you want. So one thing I have been considering, this is something that I'd kind of love to move up to the C# level as well, largely because of the dependency management part here. Like if you want to add a little bit of code that happens like right before rendering, or perhaps like immediately after input or something like that, like it might be nice to be able to insert a system that has maybe some low-level interaction or something, but can hook into that dependency tree. So that's kind of cool. Assets. So this is one of the places where StereoKit does manage data for you. And this largely relates to some of those core systems that are tricky or interesting or not worth your time. So core assets, meshes, textures, shaders, materials, those are all GPU assets. We also have sounds as well as physics objects for solids. So those are all kind of core objects that have like low-level implementations, and yeah, so you ask StereoKit to create those, and it creates one for you, and then you just hold on to it and do stuff with it. I have compound assets. I kind of like to separate these concepts apart from each other because they're interesting to think about this way. A model is not really a core asset. It contains a collection of meshes and materials. Okay, so it's basically composed of other core assets. Same thing with a font and a sprite. A sprite is just a collection of materials and textures, and a font is also a collection of textures and, I guess, technically font data. So it might kind of sort of be a core asset, but it's still kind of high level. So those are all individual things. So just to look at what exactly an asset looks like under the hood, this is the texture. So in StereoKit.h, I have just one StereoKit.h, and this contains basically all of the public API for StereoKit's C API. So you can look at that and like that's all of it. If it's not in there, it's not public. And so what I do is I define a pointer. So all you get for public access is just this public pointer. Like everything behind that pointer is invisible to you. You don't get it. And so in order to interact with it, you just have to pass that pointer into these different functions. So these functions are kind of the same for every single asset. You have a find by ID. So StereoKit does kind of have an ID system. If it encounters another asset with the same ID, it will typically return you that asset instead of creating a new one. So this is so if you are creating something and you run into this occasion where like, oh, I tried to load this model and the second time it gave me the same thing, it's because if you loaded that model once, it'll recognize that you already loaded and give you the one that was previously loaded. So find is used for that sort of stuff. There's usually a couple of different creates functions, based off of like if you're creating it from file or from memory or something like that. Asset state. So some assets in StereoKit are loaded asynchronously. So textures in particular will do kind of like a staged loading thing where it'll load the metadata, it'll load the texture information, it'll generate maps at different stages. And so you can look at the state of it to see like, did you actually load the whole way? Or are you in like an error state? Or are you still loading or something like that? You can set an ID, and then this is also reference counting based. So every time that you ask for an asset, it adds a reference, and you have to release it afterwards. So as soon as it gets released all the way down to 0, then the asset gets destroyed and freed out. So that's kind of assets. Then when you look at this in C#, the bindings are basically kind of like this. You get an int pointer, and then you pass these values down to the native API. So this is basically what the bindings to C# look like at their simplest. So you can see how there is this kind of one-to-one relationship between the C API and the C# API. Yeah, so that's kind of neat. So that's what assets look like. Here's some of the details. So if you take an asset, so that was the public side of the asset, the texture. So this is now the implementation side. It's kind of what goes into it. First thing is an asset header. So this is a little bit like inheritance in C. Basically, every asset starts with this asset header. So if you have a pointer to it, you can cast any of them to the asset header and you'll be safe. The very first item is always the asset type. Now, if you've worked with something like Vulkan or OpenXR, this might be a little bit familiar because this is kind of what they do too. Just the first item tells you the type of it. So if you look at that, like you cast it to the header, you look at the type, you know exactly what you're dealing with, and you can like switch case or something into the specific type that you want to work with. So that's the type of it. It has a state. This is the ID. So the IDs, like you saw that it was like find by ID and like set the ID, and that was a string in those particular cases. StereoKit takes the strings and hashes them to integers. Okay, so that's what this is. That is actually a string that has been hashed down to an integer. It's a little bit faster. It's a little bit smaller. And in debug builds, I also keep the string around just for like a little bit of nicer debugging. But for release mode, it's just this. And then reference counting. So this is then the texture asset itself. So like all of these are just kind of implementation details of the texture that may or may not be different, you know, from one day to the next. This is kind of the metadata information. There's a fallback texture. This is kind of like for the staged loading stuff. Like if the texture is not loaded, then it'll use a fallback texture instead. So this is, like in particular, if you have like an error, if you load a file and it fails to load, then it'll actually put like an error texture here in the fallback. So it'll still draw, but you'll just see like red checkers. Like desaturated red checkers. They're not like magenta or anything. And then this is all just kind of graphics information about like how is this texture filtered and stuff like that. Backends. So StereoKit is massively cross-platform. So I have a chunk of code for each individual platform here. So I actually have all of these implemented so far. I do have a web backend and an Android backend and a Linux backend and a UWP backend and a Win32 backend. And please don't add more. So like each of these has at least 2 different files associated with them. They do things like creating windows, or just managing the life cycle of the application, or grabbing input from the system. And actually, like the Android implementation, because this is primarily geared towards Quest, I don't have like keyboard input for that. Same thing with web. Web is a little bit, this was one I'm still working on, so it's not completely finished. But each of these just kind of has their own file. Then this is actually kind of more aspirational over here. So I currently have an OpenXR and a simulator backend for StereoKit, but it's not really architected like this. I hadn't really planned to put WebXR in at the very beginning when I started 3 years ago. So it's not really architected to fit multiple backends in the same way that I do with platforms. But this is something that I'm probably going to be changing in the next month or two. So that's something to watch out for more than to see at the moment. But this is kind of what one of those platforms look like. So this is for Win32. This is the event flow that I have, and then these are all the functions that I have to implement. So if I'm adding a new platform, all I have to do is fill those out, and I'm good. Well, I mean, that's a really simple way to say it, but it's basically that. And so you can kind of see here, like there's slightly different paths for if it's going down a flat screen sort of experience, or if it's going through a mixed reality sort of experience. Like starting in XR, starting after XR in a flat mode, or so basically, like one of the big differences that OpenXR typically manages your window for you, versus flat screen applications, you have to manage the window yourself. So that's something that you kind of have to take care of when you're doing platform work. Okay, skgpu.h. So this one's kind of neat. So skgpu was something that I wrote around, I think this was actually version 0.3, where I was adding in Android support, Quest support, stuff like that. So I had started the project as a DirectX 11 project, and in order to get onto Android, I needed something else. I actually started by trying to write skgpu in Direct3D 12 and Vulkan. But I got about a month into Vulkan and found that I had managed to clear the screen, and I decided it was a waste of my time and I'm never going to touch it again. So I instead wrote about 4 different GL backends, and I was much happier. So I don't know, someday it might be interesting to come back to Vulkan, but honestly, like if you're working on a deadline, you can't use it, and it's really disappointing. Another thing that I have kind of considered is that web GPU might be interesting. Web GPU actually has a really interesting story for its non-web experience, since browsers basically have to do this themselves. You know, like if a browser has to implement WebGPU, how does it implement WebGPU? And the answer is with native libraries. And so you can grab those native libraries and use them. So those weren't ready last time, well, like when I started doing this, but this is something that I keep revisiting every once in a while. Like, can I replace my rendering stack with WebGPU? That would be sweet. But in the meantime, this is actually kind of nice. It's a low-level abstraction over Direct 3D11 and OpenGL stuff. And so you can do a fair bit of stuff inside of whatever application that you want. And I actually do use this rendering backend for other things too. So like this is actually 100% SKGPU. It's not in StereoKit. This runs in the web. This runs with WebXR. It's really nice. And then actually, like I also maintain OpenXR Explorer, and OpenXR Explorer is basically like a DRIM GUI user interface application, but it is backed by SKGPU so that it is cross-platform, which is kind of neat. So, like, I wouldn't really recommend playing with this, but if you wanted to, it is up on GitHub. And so, related to this, one of the big reasons why I wrote this from scratch instead of using something else, because like obviously it's like, oh, why build something from scratch? Just go use a library like BGFX or something like that. That would be the smart route to take. But what I really, really wanted was HLSL shaders. I really wanted to use real HLSL to write my shaders. And so this was something that kind of shaped the direction of where I went. So what I do is I have a little shader compiler that takes HLSL and will transpile it into SPIR-V and take the SPIR-V and transpile that into a couple different flavors of GLSL. Because of course you can't just use one flavor of GLSL. And so this generates a compiled shader binary that includes multiple different shader for each individual rendering system. And so this is actually hooked into the NuGet as well as the C# project. So when you include an HLSL project, the NuGet will look at it and go, I see an HLSL, and it'll run skShaderC on it and generate these compiled shader files. So this is kind of the one place where StereoKit does need to compile your asset beforehand if you're considering a shader to be an asset rather than code. And so this is kind of what you'll see every once in a while in Visual Studio if you're looking at the output window. This is kind of what skShaderC outputs. This is the data layout of the particular shader, as well as some of the public variables that come out of it. So this is kind of nice to see. It also puts out like errors and messages like that if it encounters issues with your shader. I recently just revamped it so that those errors actually show up properly in Visual Studio. So if you have a shader error, it actually, like, you can double click on it and it'll go to the line in the shader and stuff like that, which was kind of nice. Like I've been mucking around a lot in MS Build, and that's kind of some fun stuff to get right. It's not fun to work with, but it's fun when it works. Okay. So StereoKit is an instanced renderer. So like the nice thing about like not being a game engine and everything like that is you can really simplify it. Like I don't have to figure out what lights apply to which objects. Like I don't need to chunk them up into different batches. Like I don't have to worry about legacy hardware that doesn't support instancing. And so this is kind of what it looks like for each draw call in StereoKit. And you can see like this is not a lot of draw calls. Like boom, boom, boom. Like, look at that. That's great. Like, StereoKit really instances very nicely. And because it's there by default, like, you can't actually write stuff that doesn't batch into this instancing system. So I'm really, really pleased with how this works. And it's honestly really, really simple. Like, no, that's not quite it. So this is kind of the API stuff that I do for this. So this is the concept, a render list idea. So I've been wanting to extend the rendering system a little bit to make it a little bit more flexible for other people. So I have a render list. Basically, when you say model.draw, then it just tosses in a couple of render items into the render list. And so this render list then sticks around. And when I want to execute it, it just kind of sorts it and then sends it to the GPU, and it's pretty simple. One interesting thing about this is I'd like to have multiple different render lists, so you can do like, this is the user interface and it goes on top like a heads-up display, or like this is a render list that I want you to stick with this for a couple of frames. Like one thing I've been really interested in is like decoupling graphics from the application loop, where you say like, my application just stepped once and now it's actually stuck on something. Like maybe it was doing something silly and it's taking a second for, I don't know, loading some file, custom file format or something like that. And so the application is stuck, but the rendering is not necessarily stuck. And so it just goes back to the last render list and just keeps drawing it from different perspectives. That's not in there yet, but this is something that I've kind of been thinking about with this API and would like to do in the near future. But that's kind of why it's kind of organized in that like list sort of fashion. But yeah, like I mentioned with the lighting here, like this lighting is really simple. This is just a spherical harmonics. This is just, I guess it's like 9 vector 3s or something like that, where it just does a little bit of math on them and you get some lighting information out of it. So this is really cheap to calculate, and it's just something that's globally accessible to every single shader in the application, and you can just use it, and it looks good. So this is kind of, this is the shader common include. So along with using HLSL, I really wanted to try and stay as far away from macros as I could. It was like I've had a lot of experiences with shaders and macros, and that gets kind of complicated and weird and uncomfortable. And they're hard to document right. So this is kind of the only thing that I really have that's a little bit out from your shader. This is the standard StereoKit shader include. And it has a few functions below this, but this is basically what the graphics engine passes along to shaders. The first one is a buffer that just contains like, here's the view projection, like all the matrices that you need to transform yourself from your asset space over into projection space. There's a little bit of information. So SK lighting SH, that's the spherical harmonics, that's the lighting. It's 9 float 4s in this particular case. I store camera position, the fingertips as well. Like these are really nice for user interface. Actually, like when you see the fingers getting close to UI, there's like a material.ui. And this is one of those things. Basically, when your fingers get close to it, it shows a little circle on it that indicates the proximity. It's kind of like the MRTK finger light thing. And so this is driven through this particular shader element right here. And then after that, I have cube map dimensions, time, and the number of views. Because in theory, like you could have 1 view for flat screen or 2 for this particular case. So that maybe actually be something that changes to be more than 2 in the future. I think there are some interesting use cases there for that. But yeah. And then after that, I have some of the instance-based stuff. So you can technically only put 819 instances in a single batch. Each instance is basically a transform and a color. I have some ideas about extending this in the future, but this is kind of what it looks like right now. And then, of course, the cube map as well. This is also available to anybody who asks for it. This is just kind of globally stuck into every shader material. Tools. Okay, so this is kind of an interesting spot in the architecture, and I'm not 100% sure like how exactly these should be done best. So the idea is that in some cases, there needs to be some user interface built into StereoKit. So this is the current fallback file picker and the fallback keyboard. So if the mixed reality operating system that you are currently in does not provide a keyboard or file picker, then StereoKit provides these for you. And so the interesting thing about this is that this is one of the few places where StereoKit actually does depend on the user interface system. So I've generally tried to keep the user interface system like separate from StereoKit, so it's something that can be like on top of it, but I kind of need to do these. So these are in there. They're still kind of nice. They're well packaged, and they're very helpful for some of those cases. There are some platforms where these are absolutely critical to have for interacting with us. Like on so Windows Mixed Reality, if you are in UWP, it pops up the built-in file picker right away. But if you're in like Oculus or something like that, Oculus does not have a file picker that's mixed reality based, so you have to use this one. Same thing with the keyboard. Like Windows Mixed Reality has it, Oculus does not. So this is something that I kind of hope like might go away in the future, but I don't know what that looks like in the near future. So I have these. User interface. So having come back to, so I actually spent a lot of time with Unity's editor stuff. So like, because before I came to Microsoft, I spent a lot of time shipping tools on the Unity Asset Store. Like, I got really good at Unity editor UI, and I actually kind of liked it. That might have been a Stockholm syndrome sort of thing, but I thought it was kind of neat. But leaving Unity and coming into some of the native environments and working with Dear IAM GUI, Dear IAM GUI is amazing, and I love it to pieces. This was basically like taking this editor GUI stuff that I had been using in Unity and like going to a whole nother level, and I loved it. And so this was actually what I based StereoKit's user interface off of. It's very much like Dear IAM GUI. This is, however, something that like, because so many people are relying on the user interface, and the user interface really has to be good in order to be usable for people. Like, it has to appeal to designers, you know? Like, the initial criteria that I had for StereoKit's user interface, like, it wasn't really meant to have a user interface to begin with, is it had to be fast. It had to render fast. It had to be just, like, get on screen fast. I didn't want to think about UI because I really hate being the UI guy. I have been the UI guy on so many different projects, and I really just want to be done. So that was my initial criteria. And now that I have to think about designers, I'm coming back to re-architect a little bit of this and see, like, how can I get the layout to work really well? How can I add in a few more controls that designers will really appreciate? Because, you know, once you get a designer involved, they have to feel like they're contributing. So yeah, so that may change. I'm not going to talk about the architecture of it too much as is, but this is kind of like, from a high level, like, everything is kind of composed together. Like, the button is just button at plus layout reserve. So like, there's the button system is separate from the layout system. A toggle and a button are essentially the same sort of thing, so they share their button in button behavior. And then button behavior is also composed of a couple of other primitives for like a poke interaction. So like, you poke buttons. There's another one that's like a UI box interaction for pinch. You know, basically the primitive that you're interacting with is a box, and then it has the interaction that you're doing. And same thing with the window. Window is just a handle. Handle is one I think I need to break down a bunch further, but right now handle is a little complex. That's part of my refactor in the next update. And then, oh, this is not actually as interesting as I thought it was. This is kind of like composing your own button using some of those concepts. So a lot of the core things that I just showed on the previous slide are available as part of the public API. So you can kind of take some of those things and put them together and say like, hey, this is my own funky looking button. And yeah, a lot of people actually really want to have this sort of functionality. So it's something that I think is important to the API, and it's something that I need to think about a little further and make a little bit nicer. Bindings. Okay, so like I mentioned, since it's C, C is like one of the most portable languages ever, and just about anything can bind to a C API. It's really nice. However, writing a binding is a lot of work. Like, basically, I only have the C# bindings because making the C# bindings good takes a lot of effort. You can't generate good bindings, not with just something off the shelf. And even if you could generate them, you would still have to work on them a lot more to make them idiomatic. Honestly, like, I wouldn't write bindings for a language that I did not know really, really well. And so this is kind of an interesting problem for me. I want to have more bindings for StereoKit, and I've constantly been kind of looking at like options to parse the header file and generate something interesting based off of that. So right now, I currently have a little bit of stuff. Like, I pull enumerations from the header file, and I put those into the C# file automatically, which kind of simplifies a little bit of stuff, removes a little bit of the error there. But I kind of need to go back through and rework the header file with binding generation in mind. C is not exactly an explicit language when it comes to pointers. Like, you look at a pointer and you go, is this is this an array, or is this a reference, or is this a reference to an array? Like, what's going on with this pointer? So you need to have a little bit of extra information there. It's not really built into the current set of signatures. And the other thing too, like if, like I just mentioned that you can't really generate a binding, but if you don't generate your bindings, then they become a real burden to maintain because then you have to go through and do them by hand. So it's kind of like this weird conundrum. But in the future, I will try to have some extra bindings because it's lovely to have it in C# and it's lovely to have it in C, but it would be even lovelier if I had it in other languages too. Okay, documentation. So I have a big system for documentation. This is one of those things where I really don't like writing docs. And so I tried my hardest to automate this as much as I could. So the StereoKit C# project generates an XML document. This is kind of standard for Visual Studio. And the StereoKit test project, when I run it, will execute all of the tests, and these tests generate screenshots. So I take that XML, I take the DLL, and I take those screenshots, and I feed it into the skDocumenter project. And that will parse all of those things together, and then it'll come back to the StereoKit test project, look for all these, I have kind of like comment doc tags that kind of say like, this is a sample, or this is a guide, or something like that. And so like all of my documentation are literally in that C# project, like as part of the code. And they just kind of get squished together, put into markdown files, and then that goes onto GitHub pages as part of the commit. So it's a fairly streamlined process, and this is really nice. I enjoy this a lot more than I thought I would, and it basically makes the documentation easy to maintain. So like I can basically, because this is part of the code, like if I refactor something and I change the name of something, then that refactor gets applied to all of those projects and feeds into the generated documentation. And so I know like the code is live, it's working, it's definitely correct. And so I can point people to the docs without having to caveat things, which is great. It's wonderful. But architecturally, what I have in the StereoKit test project, I have an iTest interface. And actually, like the wonderful thing about all of my systems is that they're basically just like initialize, step, and shut down. Like that's it. Like I use that pattern all over the place. So an iTest is basically an initialize, update, and shut down. And so if you have one of these and you put this in the StereoKit test project, it uses a reflection, it finds all of them, and then it runs all of them for the tests. You'll also see, like, for a lot of the screenshots and stuff that I do, you'll see this little window right here. This is basically just reflection, just going through. If there is an iTest that starts with demo, like just the name demo, then it gets put as a button here. So this is, the class for this one is demo eyes or demo geo, stuff like that. So when you click on those buttons, it's then going to that test class, which is kind of neat. So that makes it really easy to organize things in this test project. So over here you can see this is an iTest. This is testing the sprite functionality, in particular the alignment part of the sprites. Just wanted to make sure the alignments work right and don't change too much. And so I just draw a couple of lines to say, like, here's where the position is, and draw a couple of sprites. Here's the alignment for those. And then at the top, you can see here's like going to the test class and generating a screenshot. So this screenshot then gets generated every time it runs. This screenshot is actually put into the repository. So when I'm looking at my Git tool, it'll actually show me image diffs between the current version of that image and the last version of that image. So I can like visually check it and make sure things haven't changed. And so this is a really nice system for just kind of like checking and making sure errors don't slip in. And then this is kind of what it looks like. Again, this is like window separator. So this is just showing the H separator element on the UI. This is a sample of the tagging system. So I just say this is a code sample, and it applies to H separator, UI label, UI text, and UI win. Like all of those things are used in this code, and so I want this to show up in the docs for each of those elements. And then the rest of this is Markdown. So it's just like Markdown in the comments, and you can see it like there's the header, there's the image, this generated screenshot, and then here's the code that shows up right here. Beautiful. I love this. This is good. So this is a nice system, and if Usually, like if I'm developing a feature, I can usually just kind of write something like this and just look at like the output from the screenshot and just keep running it. And that's actually a really decent way of debugging some features. And this is kind of what the test application looks like. You can see it just kind of loads up each of these scenes, marches through them. Like most of them, like you don't really see anything, but yeah, kind of cool. It only takes a few seconds, but then it's generated all these screenshots, it's tested all these applications, it's generated all the docs. It even has, I have a little bit of like hand recording functionality as well. So like that user interface test that you saw there is just, you know, like a little bit of a recording there that I play back at an extra accelerated rate. And this is some of those tools in action. So like this is what I do in the demo scene. If you actually like, in front of you is usually the content, like there's a little demo window, but if you turn around, then you get to see this menu right here, and as well as a couple of other tools. Like I've got a ruler, I've got the logs, I've got like the little camera thing. And so like I can print out positions, like I can hold my finger in a spot, press a button, and I can get a pose. I can even hold my hand in a spot and print the whole hand pose. And this is something where I can actually just like input.override hand and give it that printout that I just got, and I can put that hand back into the same spot consistently. Same thing with the head, same thing with like animating the hands, stuff like that. And then this is a really nice debug camera. I still need to hook this up to some automation. Like I don't generate GIFs or GIFs, oh man, whichever. I don't generate GIFs automatically, which is something that I would really like to do. I'm only generating static images. One thing that I've been a little bit reluctant about is putting large files into Git over and over again, because I'm still not using Git LFS or anything like that. So these are all like kind of like compressed JPEGs when you see them on the doc site. Okay, and that's about it. It's a bunch of stuff. Hopefully that was interesting. I know that was kind of a little dense and maybe a little languagey, so hopefully that's cool and helpful. And I think we got a few minutes if you have questions. Thank you. Yeah. So are there plans for physics? Didn't see any physics stuff in there. So there actually is physics in StereoKit. This was actually one of the very first things that I added. I was like, oh yeah, physics, it's great, I'm gonna do that. And like some of the other things you'll see, like I'm knocking stuff over and whatever. The interesting thing is I thought physics would be more useful than it actually was. Like I added it, and then I still haven't touched it in like 3 years because it just doesn't do anything for me. So I might do more with it at some point in the future. I think in particular, I would really love to replace React Physics 3D. It's a little bit of a weird dependency. But there's, like, I'm sure there's practical reasons to have more physics. I think the biggest reason why I added it in first is because I thought I would do the user interface with physics. And it ended up being not reliable. Like, I would not build user interface with physics. It's just too much. So yeah, I don't know if that answers your question, but it is there. There's some basics. It's not like, I don't think I have hinges and stuff like that. So like some of the more advanced physics features aren't in there, but basic rigid bodies and stuff are. There is, however, a raycast intersection for a lot of different primitives. Like you can do a model.raycast or a mesh.raycast. I also have like bounds.raycast and stuff like that. So you can still do collision stuff, just a little bit more manual than like a physics system in a game engine. Mm-hmm. Anybody else? Yeah.
I always enjoy the tutorials.
Thank you.
In scenarios. What's a good scenario where StereoKit outshines?
Okay, this is a really interesting question. So it's when should we use StereoKit versus when should we use MRTK? So I would say where StereoKit really shines is iteration. StereoKit is really, really fast to iterate. It's really, really fast to build things. And the MRTK has a very robust set of user interface and interactions. Like basically, like if you see applications that Microsoft is making, they're generally made with MRTK. So if you want something that is like really polished, really ready, like looks like the operating system, like MRTK is a great place to be. StereoKit doesn't quite have the same sort of user interface capabilities quite yet, but it does do very, very well at like being able to like deploy stuff, like iterate really quickly, work with very little amount of code. The other thing, MRTK also benefits from having a game engine behind it. So if you are trying to do something that is looks really good, has this high fidelity graphics, like a really shiny experience, then Unity has those tools and it complements MRTK very well. Whereas StereoKit is basically shied away from those things because there's a lot of pitfalls with regards to performance. So StereoKit stuff isn't going to look as good, but it is more likely to perform better in those scenarios. So those are a couple of things. I think also like one thing that I've encountered a lot in my professional experience as a game developer is that after a certain point, the user interface is not really productive. Like if you have an interface with your game engine, it doesn't add as much as it should. Like after a certain point, you just have custom stuff, and the editor just gets in the way in those cases. So, you know, like one game that I worked on, we literally didn't use the Unity editor at all. Like our game existed inside of Unity, but everything was just data that we wrote our own editors inside of the Unity editor to work with. So like having an editor doesn't always give you an advantage. Being able to build good editing tools is, and StereoKit does that pretty well too. So. Go ahead, yeah.
Ideation kind of, do you want it to be like?
Yeah, so would I consider StereoKit to be kind of like wireframing for VR? I think that's actually a nice way to put it. Like, one thing that StereoKit is really good at is hackathons. Like if you want to make a product in a hackathon, I would recommend StereoKit in a heartbeat. Like it's really good at working fast. It's really good at iterating really fast. It's perfect for wireframing. I would like to say that it's really good for production stuff too, and it can be, but it's a little bit harder to get there just yet. It's why it's still pre 1.0. Yeah. Yes. Are there projects I know of that are built off of StereoKit currently? So I'm gonna point to Jumbly's Idea Engine, which is like mind mapping stuff. There's Stardust, which is a Linux operating system shell for mixed reality. But I will also say, like, a lot of the stuff that I've seen people build with StereoKit is more like research projects and stuff like that. So not necessarily like a product that you sell, but something that they're using to build something else. So like one of the people in the community who does like hand tracking for Collabora did a lot of their work using StereoKit for visualizing hand data, pose data, stuff like that. So it works really well with HoloLens research mode since it also has the native APIs. You could toss in OpenCV that way pretty nicely too. Yeah. Cool. Anybody else? All right. Thank you so much, everybody. I really appreciate it. That's all for StereoKit this talk, but I'll be around the conference. So if you want to hit me up and chat about some stuff, feel free. I'm also online at Kojaku on Twitter, as well as StereoKit has a Discord channel, and I pay very close attention to that, so you can always reach me there. Thanks, everybody.